All right, guys, welcome back. This is part 2 of Parametrics. I'm going to work example 6 and then a couple of examples on the next sheet, and we'll go from there. So first things first, there's a couple of formulas you're going to need. The first one is a horizontal formula. It is x is equal to v0 times t times cosine theta. And the other one is a vertical formula, which is y equals v0 times t times sine theta minus 1/2 times g times t squared plus h0. Please do not be discouraged by the formulas. It looks like a lot, but it's genuinely not. Let's start with v0. This is the initial velocity. So think about it as like at ground zero, like where did we start? The initial velocity. All right, we have h0, which is the initial height. All right. X is equal to the horizontal distance. Y is equal to the vertical distance. Because you might be finding how high something went, which is going to be the vertical distance. That'd be what you're solving for. Or how far did it go? All right, and you might be finding both, so that's why it's just kind of good to know which formula are going to be used based on the question that they're asking. And then we have what G is 32 feet per second, or, and that's squared, or 9.8 meters per second squared. Now, you have a big or here because it just depends on the unit of measure being used in the question. All right, so if they're talking about things, here we have centimeters, which we're going to have to convert to meters. We have meters here, so we will be using the 9.8 in this as G in this one. All right, and T is going to represent time. Okay, so Kate hits a tennis ball 55 centimeters above the ground at an angle of 15 degrees with the horizontal. Okay, so let's start with she hits a tennis ball starting at 55 centimeters above the ground. So our initial height, the h0, is going to be 55 centimeters, which we need to convert that to meters. That's going to be 0.55 meters. All right. The ball has an initial velocity of 18 meters per second. So we already have our VO as well, 18 meters per second. And then we have, it is at an angle of 15 degrees. So right now, all I'm doing is reading the problem and writing down the information that they're giving us. All right, so that's pretty much everything they've given us. First question being asked is, how long does the ball stay in the air before hitting the ground? All right, so because we're going to be solving for how long. All right, that's time. We're going to be solving for t. All right, but which equation are we going to use is important as well. So because we're looking for when it's going to be hitting the ground, we're going to be using, we're going to be using our vertical up and down. How long does it go up before it comes back down and hits the ground? So we're going to be using our vertical. And so we're going to, instead of using y, we're actually going to set it equal to 0 because that's, 0 is basically when it hits the ground. So our y is equal to 0 in this situation. We're solving for t. So I'm going to plug in the points. We have v0, which is 18, times t times sine theta, which is the sine of 15, minus 1/2 times rg, which in this case is 9.8, times t squared, plus h0, which is 0.55. All right, you're going to use your calculator, and I would make sure, like, plug this into the calculator and double check that you're getting the same thing. You'll want to make sure that your measures are in degrees and not radians because we're using sine. You should end up with t is approximately 1.057 seconds. That is how long it is in the air before it hits the ground. All right, you can also graph the equation and find where y equals 0. And that could be another way that you also find an approximate value. All right, so that's the first question that they asked, and we went ahead and answered it. If Kate is 10 meters from the net, that's a horizontal distance, which means we're probably going to be doing something with our horizontal, and the net is 1.5 meters high, will the tennis ball clear the net? Well, first we need to find out at what point does the tennis ball reach the net. We're 10 meters away, so we're going to be using this horizontal. Our x is equal to 10 because we're seeing how long until it's 10 meters in distance, which is how far it is from the net. So how long until it reaches the net? Since we're 10 meters away, that's what our x is going to be. So we have our VO, which is 18, times t, times cosine theta. Now we're solving for a different t here because the time on this one is how long is it in the air? How long before it hits the ground? Now we're saying, A, how long until it gets to the net, and is it high enough to clear the net? So we're going to actually end up using both formulas on the right side here. So once we plug this in, you will find that t is 0.575 seconds. So at 0.575 seconds, the ball is crossing the net, if it crosses the net, or it's hitting the net, right, depending on the height. Now we have to find the height. We're actually going to be solving for y using this t. 18 times 0.575 times sine of 15 minus 1/2 times g, 9.8, times t squared, 0.575, plus 0.55. Whoops, running out of room. All right, we get that y is equal to 1.608 meters. Is that higher than 1.5? Yes. So it clears the net. All right, and that is number 6. So we are going to move on to the next page and work a couple of problems there. All right. For the following examples, the initial point is at t equals 0. Thus, the domain of the function x and function y is t is greater than or equal to 0 unless otherwise stated. Solve for the rectangular equations of the parametric equations and note any restrictions. Determine the shape of the conic if applicable. All right, so for please don't forget our sine squared x plus cosine squared x is equal to 1, and our secant squared x minus tangent squared x is equal to 1. You will need those. So again, for each one, we're basically going to move everything over and set them equal to sine and cosine. So starting with the first one, if I subtract the 4 and move it over, I get x minus 4 is equal to 3 cosine t, and then I would divide by 3. So cosine of t is equal to x minus 4 over 3. All right, we do the same thing with y. I'm going to add the 1 and bring it over. So y plus 1, and then I would end up dividing by 6. is equal to sine t. Now, if you need to work these out step by step, you can. And then we end up with sine squared plus cosine squared is equal to 1. So I would do y plus 1 over 6 squared plus x minus 4 over 3 squared is equal to 1. And just to rewrite this nicer, y plus 1 squared, since we can square our denominators, we're going to do that. Plus 36, or over 36, is equal to x minus 4 squared over 9 is equal to 1. So there's my equation. And I'll slow it down on the second one and just kind of show you what I did. And this is an ellipse, since we are adding, and they are both squared. All right, so just to kind of clear things up, so I'm taking the x minus 1, I moved that 1 over and making it 2 sine t, and then dividing by 2. And that's why sine t is equal to x minus 1 over 2. All right, cosine t is equal to y plus 2 over 3. All right, and you'll end up with the same thing, x minus 1 over 2 squared plus y plus 2 over 3 squared is equal to 1, and that's where I get x minus 1 squared over 4 plus y plus 2 squared over 9 is equal to 1. And again, because they're both squared and we're adding, this is another ellipse. Okay, now last time we did a problem like number 3, I always changed x and set t equal to x, but we can't really do that here because we'd end up pulling out the t, and then it'd be t minus 2 on the inside. There's really no way to set t equal to x, but we can with y, and that's what we'll do. So t is equal to y minus 1. And that's how we're going to plug it in. So we have x is equal to y minus 1 squared minus 2 y minus 1. So then we would end up with y squared minus 2y plus 1 minus 2y plus 2. Simplifying that to be y squared minus 4y plus 3. All right, and this is a parabola. And you can even put that it's horizontal since it's x equals. All right. For number 4, we have x is equal to ln of t and y is equal to square root of t. There's a couple different ways we're going to do this. We're going to set this equal, use x and set it equal to t. So we have x is equal to ln t, and the only thing that will cancel out ln is e. So if we put e to the x, it'd be e ln, which those cancel out, so we're just left with t. Then we will replace it. Y is equal to the square root of e to the x. All right, you can graph this if you'd like. We did have one that said to note any restrictions on the domain. Our domain here is negative infinity to infinity. And again, you can graph it, but it's an exponential equation. Therefore, the domain is going to be negative infinity to infinity. So on number 5, we have y is equal to square root of t. So if I square both sides, then I have x squared is equal to t. And that is rewritten as 1 minus x squared. All right, our domain here is restricted because of the square root. X has to be greater than or equal to 0. All right, and last one I'm going to do on this video is y is equal to secant, or x is equal to secant, y is equal to tangent. So we have this bottom one here, secant squared x, which is just going to be x squared, minus y squared is equal to 1. That was nice. And then that's a hyperbola because we are subtracting. All right, we will have another part going over question 7 and the back.